Hello friends. Welcome to T Academy. In this video, I would like to provide 60 important electrical questions or MCQs for your electrical competitive exams such as a TNB or TRB or AP Genco and AP Transco or SSCGE. So any electrical exam, you can watch this video and you can learn the questions and test your subject knowledge with these questions here. Okay, let's start with the question here. So this question is asked in the previous TANSET exam. Okay, so TANSET exam, this question is asked. Dash is a part of human temperature control system. The options are digestive system, ear, leg movement, and perspiration system. So the answer for this question is it is it is perspiration system. So perspiration system is nothing but it is a process of making us sweat in our body. Suppose when you are running or walking fastly, automatically our heartbeat and the body temperature will raise, so that the skin is going to release some fluids. That's nothing but a sweat. Okay, that system is called perspiration system. It's an automatic feedback. A control system, right? Next one, which control system are generally stable systems? The options are open loop, closed loop, both, none. Okay, generally the open loop systems are more stable compared to closed loop systems. We will study all the instability concepts for closed loop system. Okay, so answer is A, open loop system. Next one, the impulse response of a system is e power minus t minus e power minus 2t u of t. Then find the transfer function of the system is. Okay, so here the transfer function is nothing but Laplace transformation of impulse response. Okay, so once you are taking the Laplace transformation of e power minus t, you will get a 1 by s plus 1. Similarly, e power minus 2t means 1 by s plus 2. So once you do this manipulation here, you will get the answer as it's not visible here, 1 by s square plus 3s plus 2. I will repeat again, 1 by s square plus 3s plus 2. So that is the answer. Next one, for the system shown in figure below, if G, that means the gain, changes by 10%, the percentage change in C1 and C2 respectively. So see here, in a open loop system, the gain is higher compared to closed loop system. That is the conclusion of this question here. Okay, so see here, G is nothing but 10% here. So in open loop system, the percentage change will be as it is that of the gain. So C1 will be of 10%, and in closed loop system, so the gain is going to be G of S divided by 1 plus G of S into H of S. That means, see here, so for unity feedback system, it is G of S by 1 plus G of S into H of S. See, unity feedback system, so we can take it as H of S as 1. So 10 divided by 1 plus 10, approximately 1% here. So the main conclusion from this question is, in a closed loop system, your gain is going to be reduces. Sorry, gain is going to be reduces, and in open loop system gain is high. That is an important point. That is the main drawback of negative feedback system. Okay, so remaining all the other aspects are good in case of negative feedback. Only the drawback is it is having less less gain. Next one, so this question is asked in IAS Electrical 2009. Find the y by x. So it's a signal flow graph question here. So this problem can be solved with the help of the Mason's gain formula. Okay, so as per the Mason's gain formula, so where we'll take a forward path gain G here, and individual loops are minus H1 and minus H2, and delta is nothing but 1 minus sum of loop gains plus sum of gain products of all the possible combinations of two non-touching loops. For example, see here, loop gains means here we have one loop and here we have another loop here, and plus sum of gain products of all possible of combinations of two non-touching loops. So this loop is not touching with this loop, so we'll take it as minus h1 minus h2 here. So if we substitute here, so 1 minus of delta we're going to find here, 1 minus minus h1 minus h2 plus minus h1 into h2. So finally what you get is this formula, this value here. As per the Mason's gain formula, okay, so only having one forward path, so we'll take it as a m into delta 1 divided by delta. So final answer will be G divided by 1 plus h1 plus h2 plus h1 h2. So what is this delta 1, sir? So delta 1 is the delta part of the signal flow graph which is non-touching with the first forward path. So you know this concept here. Next we'll move to the next question here. Which of the following is steady state error of a unity feedback with the transfer function 10 divided by s square plus 10s plus 10 applied to a unit ramp input? So main point here you need to observe here it is the steady state error is going to be found for open loop system. It is not for closed loop system. So here first we'll convert this given closed loop system into open loop system. So we use the formula here. Open loop transfer function is equal to closed loop transfer function divided by 1 minus closed loop transfer function. So once you substitute here taking this formula, you will get the open loop transfer function as 10 divided by s into s plus n here. Now we need to find the error here. What is the error? So for a ramp input we need to find the error. Okay, so kv is nothing but limit s tends to 0 s into g of s. Okay, so now limit s tends to 0 s into 10 divided by s into s plus 10, that is equal to, when you substitute the s is equal to 0 here, this s gets cancelled, finally going to be 1, and answer is the error is nothing but a reciprocal of this kv. So 1 by 1 is nothing but 1 only. So that's the answer for this question here. Next one, the initial value f of t with the transfer function f of s is equal to s plus 1 divided by s plus 2 into s plus 3 is. Okay, the initial value theorem, what it says is limit s tends to infinity s into f of s. So limit s tends to infinity s into, take this transfer function as it is, so s plus 1 divided by s plus 2 into s plus 3, and what we are doing here is we are making s common on the numerator as well as denominator. So finally what you will get it is in this form here, 1 plus 1 by s plus divided by 1 by divided by 1 plus 2 by s into 1 plus 3 by s. So finally if we substitute 1 by s as infinity, so finally get the answer as a 1 here. So answer for this question is B here. Next one, the damping ratio of the second order system which has a unit step response as shown in the figure is. Okay, so here a damping ratio we need to calculate here, and the system in the figure it shows it is a underdamped system. So for underdamped system the zeta value or damping ratio value, it is in between 0 and 1. So among the options you can see here one option is 1.0, 2, 0.414, and D is 0. So for underdamped system the zeta value is in between 0 and 1. So answer, without doing calculations, without knowing any data, you can directly put it as 0.414 is the right answer. Next one, DC shunt generator build up its rated voltage if the direction of the rotation is reversed by keeping the field connection is same, then the generator will build up its rated voltage with the same polarity, build up its rated voltage with the reverse polarity, no build up of voltage, none. Okay, see here. Generally, in case of DC shunt motor, we are having two windings, armature winding and field winding. Okay, what we are doing is the rotation, the direction of rotation, okay, reversed by keeping the field connection is same. That means you are changing the armature winding terminals. That's the meaning. So once you change the armature winding terminals, automatically the residual flux automatically is going to be vanishes. Okay, so the magnetic property of the material used in the core is going to be vanishes when you change the speed of, I mean, when you change the direction of the armature. So automatically what will happen, there will be no flux. As there is no flux, there is no flux cutting. As there is no flux cutting, there will be no EMF. So answer for this question is, it is no buildup of voltage or EMF. Next one, a DC shunt motor is running at rated speed. If the armature winding is open circuited, then the motor will rotate. Okay, so in a DC shunt motor, what we are doing is we are removing the armature winding. So once we remove the armature winding, what will happen? So simply the motor is going to be comes to rest position here. So answer is, it is 0. And the next question here, in arc welding, in order to obtain steady arc, one should use dash generator. So the options are DC series, DC shunt, differentially compound, none. So answer for this question is it is differentially compound generator used in arc welding. Why? Because the DC differential compound generator will have the capability to give maximum current at a lower voltages. Okay, so which will be useful in arc welding applications. If the load power factor of a transformer is 0.8 lag, then the primary factor is. So in case of a transformer power factor is 0.8 means the primary power factor is always less than the transformer power factor. That means here it is 0.8. That means the primary power factor will be less than that. So among the options, which value is having a lesser value compared to 0.8? Okay, 0.9 is wrong, 0.8 is wrong, 0.7 will be the correct answer for this question here. Okay, move to the next question. A 20 kVA 2000 bar 200 volt single phase transformer has a nameplate leakage impedance of 8%. The voltage required to be applied on the HV side to circulate a full load current with a low voltage short circuited will be. So when the low voltage side is short circuited will be in order to circulate the full load current. Okay, so we need to take the primary voltage, it's a 2000 here, 2000 multiplied with 8%, that means a 2000 into 8 divided by 100. I'm repeating, 2000 into 8 divided by 100, you'll get the answer it as 160. So answer is B here. Next one, distribution transformer efficiency in the range of, generally the distribution transformer efficiency in between 70 to 75% or 70 to 80% only. Okay, in case of power transformer it will be above 90%. So answer is D. Next one, a transformer having a turn ratio 1:5 and the resistance of 1000 ohms is connected across the secondary terminals. The resistance offered to a current flowing in the primary will be dash ohms. The question here it is, there is a resistance offered in the secondary terminals, we need to convert into primary side. Okay, what we'll do is we'll take the first value, K is nothing but K here value is 5 by 1. Okay, so now we'll shift the secondary resistance to primary resistance. So what the answer is, 1000 here, 1000 divided by 5 square. So 1000 divided by 5 square means the answer will be 40. I'm repeating here the formula, here it is 1000 divided by 5 square, here we'll get the answer as 40. Next one, a three-phase induction motor is running at half full load. If the fuse in the one of the phase gets burned, the motor would. So the options are come to standstill, continue to run at the same speed, continue to run at reduced speed, continue to run at high speed. So answer is the motor will continue to run at reduced speed here. A three-phase induction motor is designed to have dash resistance under running condition. So any electrical machines during running condition, it should have low value of resistance. Okay, if it's having high value of resistance means the losses will be more. Then starting condition will put the induction motor with a high resistance. Why? Because to have high starting torque. So answer here it is low. Now next question. The rotor impedance of slip ring induction motor is 0.1 plus J0.56 ohm per phase. The resistance per phase to be inserted to get a maximum torque is dash ohms. Okay, so here the condition for getting the maximum torque here it is the impedance should be matched with the resistance should be matched with the reactance. The resistance should be matched with the reactance. But here how much extra to be inserted means the difference between the two values is the answer. The difference between the two values. So 0.6 and 0.1. The answer is 0.5. Next one. A star delta starter is equivalent to an auto transformer starter with a tapping of dash percent. Okay. So an star delta starter is equivalent to an auto transformer with a tappings of 57.73% here. And we'll move to the next question here. High speed alternators are driven by, so high speed alternators are driven by It is steam turbines. Okay, so low speed alternators are driven by hydraulic turbine. Next one, the accurate method of determining voltage regulation of an alternator. We have four options here: EMF, MMF, ZPF, and none. So correct option is 0. Power factor method is accurate method of determining voltage regulation of an alternator. Next, the energy radiated by sun on a bright sunny day is dash kilowatts per square meter. So here kilowatt per square meter actually. So our answer is, it is 1.0 kilowatts per square meter. Next one, for a transmission line, the resistance, reactance, and negligible C, then means C for capacitance here, then the generator constant A is, okay. So for the generator constant A is nothing but it's a ratio of sending in voltage to receiving in voltage. So in a short transmission line, these two are approximately same. So nearby the answer is, it is 1. Then next one, more relay is employed for the protection of transmission lines. So the more relay is used for the protection of long transmission lines. In case of transmission line protection, the overcurrent relay used only up to dash kilovolts. Okay, so we have options 110 kV, 220 kV, 50 kV, 1100 kV, and the right answer is, it is 50 kV. So this question also is from the previous Stansted question paper. What is the range of voltage used in single phase electric traction system? Okay, so the options are 25 kV, 33 kV, 120 kV, 240 kV. The correct answer is, it is 25 kV. Next one, the ratio of reset to pickup current for an induction cup relay is approximately, okay, it is approximately 0.99. The surge impedance of 50-kilometer long underground cable is 50 mega ohm. For a 25-kilometer length, it will be dash mega ohms. Remember, this question is an important question in power system. Okay, the surge impedance of a cable or transmission line is independent of its length. So once it is fixed, means whatever may be the length, the value will not change. So surge impedance of the 50-kilometer long will be 50 mega ohms. For 25 kilometers also it will be 50 mega ohms only. So answer is B here. Normally Z bus matrix is a dash matrix. Okay, so Z bus matrix is a full matrix and Y bus matrix is a spats matrix. Okay, the answer is, it's a full matrix. When a LG fault occurs, the current in the faulted phase is 100 amps. The zero sequence current is. So to find the zero sequence currents here, the faulted current is given as a 100 amps. So the zero sequence current will be is equal to zero sequence current I0 will be equal to the fault current IF divided by 3. So 100 by 3 is nothing but 33.33 amps here. So answer here it is 33.33 amps. Next one. And the AC bridge used for the measurement of dielectric losses of an capacitor is a dash bridge. The options are Anderson, Scaling bridge, Wayne bridge, Hayes bridge. The answer is Shearing bridge. Next one. In a moving iron instruments, the moving iron in a direction to cause. The options are coil inductance to be constant, mutual inductance to be minimum, minimum reluctance path, decreasing the flux passing through it. So answer is minimum reluctance path. If the current through the operating coil of a moving iron instrument is doubled, the operating forces becomes dash times. Okay, the operating coil having a current of I, okay, which is I, the operating force is a T, so T is proportional to I square. That means operating coil current doubled means the operating forces will be square that of current time, so it's going to be 4. Next question here. The two holes are drilled. in the disk on a diameter of energy meter. 2. The options are increase ventilation, reduce the weight of the disk, eliminating creeping on no load, increasing deflecting torque. So we intentionally make two holes on the aluminum disc of the energy meter to eliminate the creeping error. That means the creeping error means even the meter is not a no load condition, the disk is trying to rotate so that the energy meter is going to rotate, so that the electricity department will give some extra bill for you, even though you are not using the electrical energy, right? That is nothing but the creeping error. So answer is eliminating the creeping error or no load. Next one. A coil has a certain number of turns, has a specified time constant. If the number of turns is doubled, its time constant will be. The time constant is, the options are remain unaffected, become double, become fourfold, get half. Remember here, for a specified time constant, the number of turns are doubled means the time constant is also doubled. Why? Because the time constant is directly proportional to the mm, turns. So answer here it is become double. When the networks are connected in series, it is convenient to use which parameters? Dash parameters. Okay, the options are Z parameters, Y parameters, ABCD parameters, and DX parameters. So the answer here it is Z parameters. And if the two networks are connected in parallel, it is convenient to use ABCD Y parameters. Y parameters. The ideal transformer cannot be described by dash parameters. The options are H, ABCD, G, and Z. The correct answer is the ideal transformer cannot be described by the Z parameters. Next one. A DC voltage source is connected across a series RLC circuit under steady state condition. The DC voltage drop applied entirely across the applied DC voltage drops entirely across the. So when you are taking the series RLC circuit under steady state condition, the inductor act as a short circuit and the capacitor act as a open circuit. So entire voltage will be appear across the capacitor. So answer is C. Why? Because inductor act as a short circuit in a steady state condition for DC supply. Next one, the copper behaves as a dash. Okay, so this is the tangent question here. The options are conductor, insulator, semiconductor, switch. So conductor always behaves as a, copper behaves as a conductor only. Okay, let's go to the next question here. The MOSFET can be used as, okay, the MOSFET can be used as, the options are current controlled capacitor, voltage controlled capacitor, current controlled inductor, voltage controlled inductor. So the correct option is that is a voltage controlled capacitor. So capacitor can be modeled with the help of any semiconductor devices, but inductor cannot be modeled. That is why electrical engineering is still there. It's because of inductor only. Okay, so why? Because we all study about the electrical machines and inductance in the power system. Okay, remaining all other subjects are changing because of capacitance nature. Capacitance can be modeled with the help of semiconductor devices, but not the inductor. So answer here it is voltage controlled capacitor. Okay, so if you are new to this channel, please subscribe to my channel for more updates. Okay, and press the bell icon button so that you can get the updates from my videos. And once I reach 1000 views or 100 likes, okay, of this video, I am ready to upload next video. Okay, so I can expect more views for this video so that you can expect more videos from me. Okay, move to the next question. In fabricating silicon BJT in ICs by epitaxial process, the number of diffusions used is usually, okay, it is, answer is 2 here. The type of power amplifier which exhibits crossover distortion in its output. Okay, so in which of the following power amplifiers will have the crossover distortion? So crossover distortion is the high in case of class B amplifier, so which can be overcome in class AB amplifier. Okay, so class B is the having more crossover distortion. Next one, the cascaded amplifiers are used in dash amplifier. Okay, so options are video, voltage, power, tune. The answer is it is video. Next one, the race around condition exists in JK flip-flop if J and K values are the options 0 and 1, 1 and 1, 0 and 0, 1 and 0. So when the both the inputs to the JK flip-flop are going to be 1, then there will be a race around condition happens. Okay. The highest priority interrupt in 8085 microprocessor system is. So highest priority interrupt. The options are RST 7.5, RST 6.5, INTR, trap. So answer is it is D, trap. Next one. The highest address in 48K memory in hexadecimal system is. The options are BFFFH and BFFFF, C CDEFF and D FEEF. So answer is it is BFFFH here. Okay, that is the highest address in 48K memory in hexadecimal system. Next one. The instruction queue of 8086 is dash bit long. So it is 6 bit long. The impedance inversion may be obtained with a short circuited stub, a open circuited stub, a quarter wave line, a half wave line. The answer is a quarter wave line. A VSWR can be have any value in between. The options are 0 and 1, 1 and infinity, 0 and infinity, 1 and minus 1. The answer is it is 1 and infinity. Next one. In communication system, noise is most likely to affect the signal at the transmitter, the channel, in the information source, at the destination. The answer is in a communication system, the noise is most likely to affect the signal in the channel. So answer is B here. The most commonly used filters in SSB generation are the options are RC, LC, low pass, mechanical. So the most commonly used filters in SSB generation are mechanical. So answer is D here. Next one. Telephonic telephone traffic is measured with echo cancellers by the relative cognition in terms of grade of service in Erlangs. So answer is the telephone traffic is measured in Erlangs. Triac cannot be used in AC voltage regulator for a dash load. The options are resistive load, inductive load, RL load, or a DC motor load. The correct answer is the triac cannot be used for AC voltage regulator for a inductive load. Okay, the answer is L here. Next one. A single phase voltage source square wave inverter feeds a pure inductive load. The waveform of the load current will be when the single phase voltage source having a square wave, okay, the waveform of the current will be, let's say, triangular in nature. Okay, when you have studied the inverter operation, you can observe the triangular waveform here. So answer is it is triangular C. In a DC chopper, the per unit ripple is a maximum when the duty cycle is. The per unit ripple is maximum when the duty cycle is. Duty cycle is a zero point 0.5. That means it is having the T on period and the T off period both are equal. Okay, the answer is 0.5. In a three-phase semiconverter, the firing angle equal or less than 60 degrees. The freewheeling diode conducts for dash degree. In a three-phase semiconductor, when the firing angle is 60 degrees, the diode will be conduct for 0 degrees. That means the diode will not conduct. Okay, so answer here it is D0. Okay, a DC link chopper as a compared to AC link, it is efficient, less cost, bulky, and a D is A and B. So a DC link chopper is efficient as well as it is having a less cost when it reaches the more than 500 kilometers. When the transmission line is more than 500 kilometers. Next one, name of the DC drive which is widely used in the battery operated vehicles. Cycloconverter fed AC drive, dual converter fed DC drive, chopper drive, induction motor drive. Okay, so it is the previous tangent question. It is the answer is it is chopper drive. The power electronic devices with a poor turn off gain is, okay, the options are asymmetrical SCR or thyristor or SCR. Next one is a power BJT GTO. So gate turn off thyristor GTO is having a poor turn off gain. Why? Because it requires higher amount of current to turn off the SCR GTO, gate turn off thyristor. Okay, compared to other devices. So answer is D here. Next one. And the last question, 60th question of this video. For a pure DC waveform, ripple factor is. So for a pure DC waveform, the ripple factor is should be equal to 0 here. Okay. So thank you friends. Thanks for watching my video. So please subscribe to my channel and press the bell icon button if you are new to this channel. And if you are already my subscriber, please give a comment on this video. Okay, so once it reaches threshold value of 1000 views and 100 likes, I will ready to upload next video. Why? Because your exam is having in the next month of TNEB, okay, and tangent examinations, right? So all the best for your examination. Prepare well.